good afternoon, everybody. I heard a comment a little bit earlier about an elephant in the room. I'm probably going to deal with a few elephants, possibly a herd of elephants in the room here. But my name's Gavin Allwright. I'm the Secretary General of the International Windship Association, which was formed back in 2014. And obviously this is the year of the dragon. Now, a dragon ship usually doesn't have a sail, ours does. But what I'd like to say is, usually in perception-wise, most people think of wind ships as Jack Sparrow on the Black Pearl in the Caribbean having lots of fun. We're not talking about rewinding, we're talking about rewinding. So it's rewind, not rewind. Very quickly, the International Windship Association is over 200 members, including some of the biggest shipping companies and charterers. We have shipyards, but mainly we're focused on the technology providers, R&D centres. We have 5 class societies, including DMV, which I'll be speaking in a moment. Scattered around the world, we have some clusters, and if I've got time, I'll go on to talk about those a little bit. But we're a trade association representing pretty much all of the wind propulsion sector. Now, very quickly, MEPC 80, we had the decarbonization strategy. I think you all are pretty familiar with that. But please remember that the 5 to 10% that is often quoted around fuel actually isn't only fuel. It's fuel, energy, and technologies. So 5 to 10% by 2030, fuel, energy, and technologies. Now, we actually see the IMO 2030 strategy of 20 to 30% as a floor, not a ceiling. We can go faster if we so choose to do. We could roll out wind across the fleet, and I'll show you how that maybe is possible in a moment. So we've got to remember that to align with Paris, the Paris Agreement of 1.5 degree reduction, 30% is just to keep in touch with it. It doesn't align us with 1.5. And a CE Delft study that was released during MEPC 80 put together a 5 to 10% fuel, a low emissions fuel component, along with wind propulsion, energy efficiency, and voyage, actually not voyage optimization, only speed. But with those 3 components together, we could achieve 28 to 47% reductions in emissions by 2030. That's a significant dent, not just delivering 2030, but that's a significant dent into 2040 as well. Now, wind propulsion. Okay, so we can run the energy through a standard fuel production system. For every 10 units of energy that's delivered to a wind turbine, the amount of power or the propulsive energy that comes out of the ship will be about 1 unit, possibly 2. So we're wasting 8 units of that energy. Now, that energy could be used in other sectors. With wind propulsion, you're delivering it directly to the ship at the point of use. 100% of that energy, or near enough 100% of that energy, is being delivered through there. And it's not being delivered through the propeller, it's being delivered directly to the ship as thrust. So don't think of it as energy efficiency, think of it as energy provision to the vessel. And this is a pure zero emissions energy source, not just greenhouse gases, all emissions, including underwater radiated noise. So if you're putting anything for a propeller and you have cavitation, you have noise, you have emissions. So wind is simply the only propulsive force that is moving a ship at zero emissions. And we like to, I can go through all of this, but I've only got 7 minutes and 44 seconds, so I better be quick. Basically, this doesn't need to be mined, refined, transported, stored, bunkered, or stored on the vessel. Okay? So there's zero development time. We have quite a number of technologies already in place. Compatibility issues. It's compatible with any other energy source that you choose. If you want to burn a fuel, fine. HFO and wind, no problem. Haven't quite worked out nuclear wind yet. Maybe we have a little fan blowing the sail, but anyway, working on that one. And zero capex on here, question mark. Well, actually, wind is the only propulsive system that is going to deliver, is an energy source that's free. Therefore, it has a return on investment. Everything else is likely to be more expensive than the existing fuels we're using today, until that's equaled up either by subsidies, taxes, or whatever. But the zero capex is basically you could lease these systems. And actually, the Global Centre for Maritime Decarbonization is working on a pay-as-you-save model. Well, this is a classic example of that. And somebody was asking around how much energy can be delivered. 5 to 20%, possibly optimized up to 30%, if you're not weather routing. Yeah, so if you're weather routing for wind, you can go to where the wind is blowing stronger, and those numbers go up. If you're looking at a new build, then actually we even have a climate positive ship under development by MOL, which actually would use excess wind to generate fuel on board, but store it in tanks to be offloaded as a product as well. Now, we did a survey in the middle of last year, and usually energy surveys, or the energy mix that the options are given, are just the fuels. We threw in wind assist, and primary wind as well. And interestingly, we had 84 in total responses. These are from ship owners, stakeholders from across the industry, not wind proponents. You know, there were a few in there, but not many. And policymakers, flag states, etc. And the pattern of fuel, they were given 5 options to choose from. And the pattern of fuel came out pretty much as it always does. So you'll see that on here, and you can have the slides later. But when wind propulsion was included, that became pretty much the top option for 2030 with wind assist. But if you took it out to 2050, it was even more popular, and primary wind went right up the scale on that. So that's all great. We looked at the vision, brilliant. What about now? Well, we have 39 ships in operation with wind installed. These are large ships over 400 GT. About 2.5 million deadweight tons of shipping have wind installed. We have another 11 wind-ready vessels. So those are awaiting the systems, have the foundations put on, or they're waiting for costs to come down for the actual systems to be installed. The EU's forecast up to 10 to 15% of the fleet by 2030 would have some form of wind installed. The UK government forecasts 40 to 45% of the world fleet by 2050. We think both of those are conservative. Obviously, we hear a lot about the policy pressure coming forward. That line, that checkered line through the middle, is those forecasts. Basically, we're seeing an uptake or an inflection point around about 25, 26 in the regulation. That matches with probably around 200 installations of wind propulsion vessels. Now, I just want you to imagine if we were to roll out wind across the fleet, every single ship has some form of wind put on it, maybe mandated. I don't think IMO is going to mandate it, but there we go, we can only wish. That would save pretty much 20% across the fleet. So large vessels retrofitted, maybe 5 to 10%. New build primary wind vessels, 50, 60, 70%. Averaging out, let's say 20%, with a bit of wind routing in there as well. The amount that would save by 2050 would pay for all the other decarbonisation. It would pay for itself and then cover the price tag for everything else. All the fuel infrastructure and the transition of the vessels into dual fuel or whatever you're going to do. And this again is the innovation curve. We have to remember there is an urgency here. We can't wait for fuels that are 2035, 2040 coming into the mix. We have to be making these changes now. And unfortunately, This is an innovation curve. We don't seem to understand this is also a climate curve. Climate doesn't go in a nice line. Oh, next year it's going to be a little bit worse than this year. Next year, well, last year, for example, the Amazon forest stopped being a carbon sink and became a carbon emitter. That is absolutely shocking. The oceans, tipping points, etc. So, just very quickly, because I've got 2 minutes, a couple of ideas just around the regional development. This one's in China, it's already out of date. I made these slides about a week ago. We've had 2 more installations since. But this gives you an idea of some of the technologies, but also the size of some of these ships. If you're down in Singapore port, you may see the there's a Berg bulk vessel and the MV Pixus as well, with very large wing sails on them. Yeah? A lot of people are always asking me, oh, how much does it cost? Da, da, da. You know, is it safe, etc., etc. All the barriers, we go through them all. And they say, I still don't want to buy one. And you say, well, why not? I'm not sure. So we can have it in any color you like. All right? And as you can see, any color is perfect. We also have massive regional development in France at the moment. Really big cluster. We have another one in Finland, developing one in Germany. America's a little slower. South Pacific, we have a big hub as well there where we're developing smaller vessels. But this just gives an idea. I think there's over 100 companies interacting with wind propulsion. We're looking at hundreds of thousands of quality jobs in the R&D, installations, and remembering a lot of these systems can actually be installed during service. They don't have to wait until they're in dry dock. I'm not going to go through all the barriers because I've got 20 seconds. Just very quickly on some of the trends. Primary wind, as I mentioned. We also have the something that's very important is the wind routing optimization, using LiDAR to actually map out where the wind is coming onto the vessel so we can optimize the systems. And a key point, I'm just going to leave it on this one, is the scaling of production. So, as I mentioned, we're already at 50 vessels, 39 installed, 11 wind ready. A lot of what the yards say to us is to say, okay, we're going to get a ship owner come in and say, can we have 50 of these? Now, and one of our providers turns around and says, oh, yeah, that's 18 months. Yeah, the ship owner's not going to wait that long. So our members are already investing hundreds of millions into production lines. 3 of them have moved production lines to China. We have others setting up in the south of Europe. We have a couple of primary wind vessels under construction in Turkey as well. The scale up is already happening. You know, we're at probably high hundreds of unit capacity. We need to be in the thousands by that inflection point, 2025, 2026. And we like to call all of this win-win-win situation. So I know I had to drop that in for you, Apple. So thank you very much, and of course these slides will be available to you for afterwards. Thank you.
Thank you. Thank you.